I'm Phil Grant. I'm a software engineer at Sencha, where I work on the frameworks team. And I've had the opportunity to work on a lot of the theming-related stuff in the past. And so really excited to talk to you about fashion today. So as many of you know, fashion has a couple definitions already. One would be a popular trend. Another would be a manner of doing something. And I'm very excited today to announce that there's a third definition coming to a dictionary near you. And that is a brand new, blazing fast SAS compiler from Sencha written entirely in JavaScript. The developer achieved amazing improvements in productivity by using Sencha Fashion to compile his application CSS. So before I go into fashion and explaining what it is and how it works, I'd like to take a moment to just review kind of how we got here. I think most of you are already familiar with the backstory on this, but for those of you who don't know how to spell SAS yet, in the beginning there was CSS, and it had many shortcomings, not the least of which was the lack of variables. So if you wanted to create an API around your CSS, you had no way to do so, and you had to just recreate everything from scratch. As a result, it was not dry. You had to repeat yourself. You couldn't follow the don't repeat yourself rule. Everything you did in CSS had to be repeated over and over and over again, and so therefore it was very difficult to maintain. There was no way to achieve code reuse. And so, how many of you ever wrote an app that was styled by hand? A lot of you. You end up with these huge CSS files, right? And they grow and grow over time, and the old code that's not needed anymore stays there, and new code gets added, and eventually it gets so out of control you have to rewrite your entire app. So along came SAS, which stands for Syntactically Awesome Style Sheets. And it was great because it gave us a lot of things we never had before. It gave us variables, so now we can basically just set some variables and have it generate some CSS that uses those variables. We can distribute our code as a library for others to use those variables. It gave us nested rules to eliminate some of the repetitive nature of parent-child selectors. And gave us mixins to help to maximize our code reuse. Finally, it gave us functions. SAS has a lot of built-in functions for manipulating colors, for doing math, for manipulating strings. All that was just super handy, and we were so happy to have it when we found out we could have these things. So for those of you who haven't been introduced to SAS yet, which is very few of you, so I'll speed through this part. Variables work kind of like this. You've got in this example, you have a base color, which is red. And in our body rule, we use the base color variable to assign the color of the body element. And so when you compile the SAS, you end up with a resulting CSS that looks something like this. And so we can use these to create flexible APIs that we can distribute for others to use. Nesting is also a handy feature of SAS. Parent-child selectors are often cumbersome because you have to repeat yourself over and over again. So on the left, you have the SAS, which shows you a panel which has two child elements, a title and a body. And when we compile it to CSS, each resulting rule has that panel parent selector. You can nest these in various ways in SAS. You can hoist inner rules outside. You can chain them together. Mixins were a lifesaver for us in Ext JS 4. We needed a way to style panels and buttons and windows and form fields in ways that where we could reuse the styling but yet have many permutations of the same component. And so mixins are how we achieved that. If you've ever styled using Ext JS, I'm sure you've seen this. So we have a mixin definition which has parameters header color and body color. And then inside the curly braces, you have the body of the mixin. which defines the rules. And those rules use the parameters that were defined in the mixin definition. And so all we have to do is invoke this mixin by calling @includePanel, and we're passing header color green, leaving the body color the same as it is in the default that is declared in the panel mixin definition. And so the resulting CSS gives us a panel header and a panel body with color green and white. And we can call this mixin over and over again to generate many kinds of panels. Finally, there's functions. Sass includes a lot of default functions like lighten, darken, mix for colors. You got math functions like min and max, string functions. And these are all available out of the box in Sass. In this example, we're taking a base color and we're passing it to a lighten function, and we're lightening it by 10%. And the result is a new color. And if you've ever looked inside the source code of Ext JS, you've probably noticed that we do this all over the place. And so these things were a lifesaver for us until CSS3 came along, and we needed a way to make sure that our CSS3 styling worked across all the browsers. So then there was Compass, which is a library built using Sass. It's a Sass framework, and it does many things, but the most important of which, for our purposes, was cross-browser CSS3. So for example, when I need a panel with rounded corners, I don't have to worry about what all the different syntax is for the various browsers that support this. All I have to do is call a compass function, include border radius 5 pixels. That's all I have to say, and Compass does the magic and gives us something like this. So we have a Moz border radius, WebKit border radius, and border radius. And it figured out what we needed for the browsers we were targeting, and it just did the magic for us. So Sass and Compass and Ext JS 4 and 5 were a match made in heaven. They really were the best tool for the job at the time. It really allowed us to design a really flexible API that allowed you guys to customize your themes and your apps in really awesome ways. And but it had some shortcomings, which brings us to today. So one of the big shortcomings of the system was that it had a dependency on Ruby. So if you wanted to install such a command and build your app, first you got to go get Ruby. But perhaps the more important side effect that we wanted to get rid of was this cycle of build time compilation, which meant you had to make your edits, then run your build, then refresh your page, then go back and edit again, then run your build and refresh your page, and repeat over and over again. And if you had a really big app that takes a while to load in development mode, you're sitting there for a few seconds waiting for refresh, you're taking a while waiting for the build, and it's cumbersome to deal with. So we wanted to make that cycle easier for you guys, and that is why we invented Fashion. Now, some of you are probably thinking, I know of another JavaScript-based CSS precompiler, and it's called Less. And why didn't you guys just use that? So I'm going to tell you why we didn't. We did indeed evaluate Less, and we thought it was good. I liked Less. It runs in the browser, it's written in JavaScript, it's fast, but it didn't have all the features that we needed. Certain things like default variables and conditional statements weren't available, or they were implemented so much differently that they would have a big effect on the way we do theming. And secondly, and perhaps more importantly, Less was incompatible with the current syntax that you guys are familiar with, that you're used to using in your applications today. And so if we went and jumped from Sass to less, you guys would have to rewrite your entire themes and all your code for your applications that you're using for styling your apps. And we didn't want to do that. We wanted the upgrade from Ext JS 5 to Ext JS 6 to be as seamless and painless as possible. We want you to be able to use the same familiar syntax that you're used to. We want your existing themes and apps to just work out of the box. We don't want you to have to change the way you do things. And so that's perhaps the most compelling reason that we didn't go with less. So that brings us to today, and I'm really excited to announce that we have Fashion, which you guys saw at the keynote. And today I'm just going to dive in a little bit deeper, show you some more details on Fashion, how it works internally, and just try to give you guys a good idea of where we're going with this. So Fashion supports all the familiar Sass-like syntax that you're used to. When we built it, we had it in mind that we wanted it to be able to compile our existing themes that we had in Ext JS 5. And we wanted to be able to compile our apps, our examples, everything, all the existing things that we had, we wanted to work. So that was our initial target. Instead of picking a version of Sass that we wanted compatibility with, that was our initial target. And then we went further and we're targeting Sass 3.17, which is the version of Sass that Ext JS 4 and 5 use. In the future, we're planning to enhance it and incrementally add newer and better features of Sass that are supported in mainline Sass. But for now, it is a work in progress that is targeting the existing frameworks and themes. So it supports variables, mixins, functions, nesting, all the things you're used to. The other thing that Fashion does, as you saw this morning, is compile Sass into CSS on the fly in your browser, which eliminates this repetitive cycle of edit, build, refresh, edit, build, refresh over and over again, because it's all in your browser and happens almost instantaneously. And finally, Fashion includes a really exciting new JavaScript API for creating custom extensions to the Sass API, which used to be difficult because it had to be done using Ruby, which most of us are not terribly familiar with. So exactly how fast is Fashion? Well, I hope you guys were impressed by the demo this morning. But I'm just going to go ahead and dive in a little bit deeper and show you a little bit more detail on exactly what Fashion can do. So the first thing I'm going to do I'm going to open an app that you guys saw this morning at the keynote, which is the Sencha Inspector. Now this app, we're not releasing this app today, but I can go ahead and show you. I've got a dev build that I'm using that I can go ahead and use to show you guys how it works. So I'm going to put that over there. And then the second thing I'm going to do is I'm going to switch over to my IDE, or to my console here. And I've got an app open here. Can you guys see that okay? I've got an application here that I've generated using Sencha command. This is the same app that you all saw during the keynote. It's the starter app that command gives you when you type Sencha generate app. And so I've gone into my application directory, and it's just a plain starter app. I'm going to type Sencha app watch. How many of you guys are familiar with Sencha app watch already? Most of you, good. Okay, so what Sencha app watch does is it monitors the file system for changes. When changes occur, it recompiles your SAS. And it has done this all the way back, going back years ago, since years ago when it was first implemented. So it's nothing new, but it does have a new feature to it, which I'll get into shortly. So right now it's monitoring the file system for changes. If I change something in my SAS code, it'll go ahead and it'll recompile all of my SAS for me. So now that I've got that running, you'll notice that here at the bottom, it says application available at localhost port 1841. So what it's done there is it's gone ahead and AppWatch has started up a web server for me, and that web server is running my application. So if I go visit that in my browser, I can see the starter app as it was generated by Sencha command. So now if I go look at Sencha Inspector, we'll see that it shows this application here. But there's one more thing I need to do in order to make it work with Fashion, and I need to add a parameter to the URL that is platform tags equals fashion true. Now when I go to Sencha Inspector, I think that one that we had there might have been an old one. Let me open this up again. Okay, and there it is. So I'm going to go ahead and click on this application here in Sencha Inspector. And then this is the window you guys saw this morning in the keynote. It's got all kinds of information about your app, including components, stores, and layouts, events, all kinds of useful things. But we're just going to go over here and click on the Theme tab. Let's put these side by side so I can look at them together. Now let's go ahead and change the base color. Now watch, I'm going to click OK here, and boom, instantly updated in the browser. Now, when that happened, it didn't just update those two elements, those two panel headers. It went and recompiled all of your CSS, all the variables that derive from other variables that derive from other variables, all the way down. It evaluated those again and recompiled all the rules based on the new inputs. So what if I want to do more? So this list here includes thousands of variables, and fortunately they're prefixed by the component that they belong to. So first of all, I can go ahead and change some global things like font family. Let's say I want the font family to be different. I want to use the same font family that Sencha is using for all the presentations this time around, which is Clavica. There you go, updated, done. But I don't like the font size, it's too small. So let's go ahead and fix that. How about 15 pixels? Hey, much better. Now I can see my text a lot better. But I just don't like the way that grid looks. It's just, I don't like it. I want to change it. I want those headers to be a different color, the grid headers. So I can type $grid in here, and there's all my grid variables. So let's say I really just don't like the color of those headers at all. So I'm going to find that variable. So let's see here. Oh, there it is, grid header background color. See, there it is. It's a light gray. I'd like it to be a dark gray. Let's do somewhere about like that. Well, that's great, but now the font in the headers doesn't match. So we can fix that real quick. Hey, there it is. Grid column header color. That'll work. Let's make that to be a really light gray. Done. Instantly updated. Suppose I want to change the font in the grid. Well, there's a variable for that too. Font family. Let's pick something interesting this time, like, I don't know, monospace. Bam. Look at that. Look how many changes we've made to this app. It looks completely different from what we started. We haven't left the browser. We haven't done one page refresh. It's all right here. So there are a few things that you can't change, as of right now anyway, that we can't change using this technique, because all this is showing us is all the global variables that are in global scope in Sass. And so if we're calling a mixin, for example, we can't change that this way. So in order to do that, we've got to go into code on the file system and edit some code. So let's go ahead and do that. So the nice thing about having AppWatch running is that it starts this web server up, which hosts your application. And the application, when I've started it in the browser over here, let's open the console so you can see. You'll see a bunch of output in the console here, and what's happening here is this is the output from Fashion as it's compiling and recompiling your theme. What it's also doing is it's polling that web server that AppWatch just started for us. So the browser is polling that server at regular intervals to find out when there are changes on the file system. So if I change something on the file system, two things will happen at the same time. It'll go ahead and recompile at the command line, and the browser will be notified, and it'll recompile. Fashion will rerun in the browser and recompile the CSS in the browser as well. So let's go ahead and try to see if we can see that in action. Let's try brown. So see, my AppWatch picked that up and it kicked off, and Fashion picked it up as well. And it looked like that one was even faster because Chrome is just lightning fast at this stuff. So the browser actually finished before the command line got done recompiling in that case. So the real usefulness of this is when you have things, like I mentioned earlier, that you can't change using the Sencha inspector. So to demonstrate this, we're going to go into one of our Sass files for the app that styles the main view. And so let's open up main.scss. And you can see here that we have an include Ext JS tab panel UI. And this is what generates the styling for this dark gray tab bar over here on the left side of the app. And so in order to generate that styling, we're invoking a mixin that the framework provides. We're generating a UI called navigation. And so let's just say, for example, that I wanted to change the font size from 15 to 25. Let's save that. Boom. So still lightning fast, because all the browser had to do was wait for the notification to be sent, and it didn't have to do any refreshing or reloading of files. It just instantly recompiled on the fly. So I hope that answers the question. How fast is fashion? Really fast. It really makes things a lot easier when you can do it all right there in your browser without having to go back to the command line, back to your editor, edit, save, refresh. It's just so much better. So now that we've kind of seen how fashion works, let's go a little deeper and let's look under the hood and see how exactly it works under the hood. So first of all, we'll talk about compiling, how the compiler works and what makes it so fast. And then I'll jump in a little bit and show you guys how to debug fashion. And I'll also introduce you to the JavaScript APIs, which you can use to write your own custom extensions to fashion. And finally, I'll show you the techniques that the App Inspector uses for inspecting the variables, for showing what variables are available to fashion and how to update those and change their values. So first, let's talk a little bit about the fashion compiler. So it all starts with Sass source code, which is stored on the file system in your themes and in your applications. And that Sass source code has to get into the fashion compiler somehow. And right now, the only way for it to do that is to be loaded into a browser via Ajax. And so you might be thinking, well, how does it run from the command line then? And the answer is we run a headless browser called Phantom JS on the command line, which uses the same exact techniques as you see when it's running in Chrome when you can see it. So basically, the browser just Ajaxes down all of the source code, all of those Sass files from your theme, from your app, any third-party Sass you're loading. It just Ajaxes that all into the browser. And then it goes into this big black box called the fashion compiler. And the fashion compiler does its thing. It operates on the Sass source code, and it outputs a big, giant JavaScript function. And that function represents a JavaScript representation of all of the variables, all the rule definitions, all the mixins and functions that were defined in all those Sass files that you imported. And so all we have to do is invoke that function, and out comes CSS. And this is what makes it so incredibly fast, is that those first two steps here never have to be repeated. All we have to do is invoke that function again with different inputs, different variable values, and it runs and generates you a new style sheet. So now that we know how the compiler works, can we leverage that to do some debugging? One of the most frustrating things for me, and I don't know about you guys, was trying to debug Sass code, because there was no way to put breakpoints in it. So I end up having all kinds of @warn and @debug statements all over the place trying to figure out what was going on. So hopefully we can improve that for you in fashion and make your lives a lot easier with the new @debugger directive. And what you can do is just drop this in anywhere in your Sass source code, and it ends up inserting, remember that function I told you about, that big function that fashion generates? It puts a JavaScript debugger statement into that function at the appropriate line where you inserted it in the Sass code. So what that could look like is maybe something like this. You define a variable, then you have a rule later on, and somewhere in the middle, you put @debugger. So let's flip over to code real quick and see what that looks like. So I'm just going to go to my all.scss file that I have here in Etsy just for sake of convenience. And I'm going to go ahead and put @debugger right here. And now watch carefully here, because this is going to happen quick. I'm going to hit Command S to save this. And then I'm going to tab over to Chrome, and boom, I've hit a debugger. Fashion picked up that change, ran, and hit my debugger. Now hopefully I can make this big enough for you guys to read. So disregard this highlighted line. This is Chrome's DevTools got the line wrong. But it did pause on this debugger statement here. Now you'll see two kinds of statements in here. You'll see gets, get calls to the get function, and then you'll see calls to the set function. And what these are just Fashion is getting and setting variables. So you could, if you wanted to, call these functions in your debugger and see what you get. So let's try that. So down here in my console, I'm going to type get $base color. So I want to find out what the value of that variable is right now at this point in the execution of the code. And it has not yet been defined because I'm doing this in the etc all file of my app, which comes in before anything else has come in. So if I want to, I could put it after I've defined base color. And I could try that again. And it gives me here what's called a fashion.color instance, which has all the information about the color in question. So likewise, if I wanted to set a color in here, I could just call the set function and set its value. So while we're in here, I wanted to just take the opportunity to show you this function so we can really get a feel for what it is and what it does. So this is the beginning. It's just a big giant function, and most of the things you'll see immediately are a whole bunch of set calls to set the value of a bunch of variables. And then you'll see in here, you'll see mixin definitions. So here's a mixin called text shadow, which generates text shadows and outputs some rules. And then the third thing you'll see, and we can see one inside this very mixin, is a rule set. And rule sets are just JavaScript representations of CSS rules. There's other things in here like the declare function, which declares a property. So in this case, we're declaring a property called text shadow within this given rule. And then there's more get and set calls. So you can go through here, you can debug through here, step through here, just like you would any other JavaScript function and figure out what's going on. So I think that's pretty cool. I am really happy to have this because I've been wanting to debug my SAS code for years. So I mentioned earlier that Fashion provides a pretty neat JavaScript API for writing your own custom extensions. So let's dive in real quick and see how that all works. So if you've ever used SAS, you know about the import directive, and it's always been used to import other SAS files. In Fashion, we've extended it to include JavaScript files as well. So when Fashion encounters an import statement, if the name of the file that's being imported ends in .js, it assumes that it's a file that contains Fashion extensions. And so these extensions are available in scope anywhere from your Sass code. You can invoke them from Sass to return whatever values you're needing. So an example of that might look something like this. In Sass, we say @import extensions.js. And then in our file named extensions.js, we put something that looks like this. So we call fashion.runtime.register, which is a function that just takes an object literal that has functions in it that we want to expose to our Sass code. So real quick before I go on and talk about fashion types, let's write a fashion extension. So I'm going to go ahead and, since the Etsy all file is in scope, it's a convenient target for me to do this in. I'm going to go ahead and make a new file in my Etsy directory. And in here, we're going to say fashion.runtime.register. And we're going to pass it an object literal. And in here, this is how we tell Fashion what functions we want to register. So I was looking at Less the other day and noticed that it had a few functions that Sass does not yet have. So I decided, hey, why don't we implement one of those in Sass just for fun? So the function is called multiply, and it takes two colors. And how it multiplies the colors together is it just takes the individual RGB channels of each color and multiplies the red channel of one by the red of the other, green by green, blue by blue, divide each one by 255, and construct a new color with the result. So that seems pretty easy. I think we can do that. So let's say var r equals color1. Now color1 is a Sass color type, and I'll get more into Sass types in a second. But for now, let's just say it has a R property, which is the red channel. And we're going to multiply times color2 dot R, divide by 255. Do the same thing for green. And finally, the same for blue. Okay, so now we have our new red, green, and blue values. Let's make a fashion color and return it. So let's return new fashion.color. And it takes R, G, and B arguments, and for the alpha channel, we'll just use 1. And that's pretty much it. We've written a fashion extension that takes two colors, returns a new color. So now we need to be able to call this function from our Sass code. So to do that, I'm going to go over to all.scss in my Etsy folder of my app. Simply because that's a convenient target for this demo. You could put these anywhere you like. And I'm going to get rid of these variables, and I'm going to say @import, and I'm going to put in the name of that file I just created with my extensions in it. Okay, well that's all I needed to do. Now my multiply function is in scope, and I can call it. So since we've been having so much fun with the base color, let's use it to set the base color. Base color, multiply. We're going to multiply orange times gray. Okay. Well, that's interesting. I think when I hit that, when I hit that debugger, something went wrong. So, such is the case with live demos. But that's all it took. Now we've written a fashion extension. You can write these in JavaScript, write anything you want in there. Saves you from having to learn Ruby. I don't know about you, but I like that. So real quick, let's talk about those parameters that come into your fashion extension function. What are those things? What kind of variables are those? So first of all, we have several fashion types which wrap native JavaScript types. So we have fashion.bool, which wraps a Boolean, fashion.number wraps a number, fashion.string wraps a string, and fashion.list wraps an array. Additionally, fashion has several other types, like color, the one we just used, and color stop, linear gradient, and radial gradient. Now, we don't have time to go into all the details of all of these, but if you're interested in knowing more about how these work, that's interesting. All you have to do is go into your command install. So when they send out the email later today with the link to get the preview release of Command 6 and Ext 6, you can download such a command, and when you unzip it, you'll get a directory that looks something like this. When you install it, it'll go into your install directory, your bin directory, and it'll look something like this. And all you have to do is go into Extensions, Sencha Fashion, Fashion, and then Source. And that directory contains all the fashion source. You can go in there, you can look at the compiler, you can look at the runtime, you can look at all the types that the fashion type system has, and get all kinds of information about those. So just a couple quick notes. When you're using a fashion type, you use the value property to access the underlying JavaScript value. So for example, if I have a function that takes a string, I can say if string.value equals foo. And also important to remember, when you're returning a value from a fashion extension, you always have to return a fashion type, because this value is consumed by Sass code, so it can't deal with JavaScript types. So in this case, as you saw earlier, we returned a fashion color from our one that we wrote. We could return a fashion string, a color stop, a linear gradient, any of those. So how does the Sencha inspector work? I'd like to give you just sort of a quick preview into that. So there's an API for inspecting the variables that Fashion has available to you, and that is fashion.getVariables. And what it returns is a simple object that looks like this. Could have thousands of things in it, could have only a few, but it's just a simple object where the keys are the variable names, the values are the variable values, the current values. And then if you'd like to change those, you can call another function to update them called setVariables. And it takes an object of the same form, doesn't have to contain all the variables, just the ones you want to change. And this is no lie, this is as simple as it is. This is exactly how Sencha Inspector does its magic to update the variables that you saw in the demo. So, additionally, we can do interesting things from within the set variable call. So if I go back to my browser, and I say fashion.set variables, I can set the base color to blue right there from my command line. You could do that with any variable you wanted to. Perhaps even more exciting is that any function, any SAS function that's available to you, including the custom ones that we've written, are also available for you to use too. So I could go ahead and put multiply orange purple, and I'm about to invoke that function that we just created earlier right here in my browser console. And there it mixed orange and purple together to get my base color. One more thing that you guys might find useful is when inspecting the variables, if I do fashion.getVariables, I'll find that it has an object which, if I can find my mouse cursor on the screen, oh, there it went onto my laptop. It has an object which, as I said earlier, it's got the variable names over here and the values over here. Now you'll see these are just string values. These are not the actual fashion types that fashion uses under the hood. So this is the format in which you would pass it to fashion. And then fashion would evaluate those variables and those values and turn them into the types that it uses. But if you need type information, you could call fashion dot runtime dot get global scope, and this function will give you all the variables in global scope as fashion types. So I can go ahead and inspect this object, and I can see things like, if I look at the accordion header color, I can see, well, what kind of object is this? And if I look at the prototype chain, I can see that it's actually an instance of fashion.color.rgba, so it's a subclass of fashion.color. And I can see the RGB and alpha values right there on it. If I look at accordion header border width, I can see that this one is a fashion.number. And being a wrapper around a JavaScript native type, it's got a value property, a value of 0. And so I could inspect any variable in this manner and see what kind of fashion thing it is. So these ones are Booleans. Here's a string. So it wraps, it's of type fashion string, wraps a native string. If you look at the value property, it's the JavaScript string value. So there's so many more things we could talk about and dive into, but I hope you guys have an opportunity to download the latest command and try it out for yourself and see how it works, and send us any feedback you may have on the forums. So with that said, just want to leave you with one final thought. I know you guys already saw this earlier, but I just wanted to see it again because I think it's so cool. It's not just changing those 3 colors. It's recompiling the entire theme, the entire app CSS from scratch, reevaluating all the variables, and it's doing this multiple times a second. So I don't know about you guys, but that's fast enough for me. So I'll go ahead and take your questions now if you would like to just come up to the microphone, and I'll do my best to give you an answer.
So is there any way to persist your changes that you make on the browser back to the source?
There will be. There will be. Not right now, though. And the Sencha App Inspector, like I said, we're not releasing it today. It still has some work to be done, but yes, there will be a way to export those values, and I'm not sure exactly how that'll look. Maybe we'll give you a file, or maybe we'll just open an editor with the values, you can copy them to your file, or we'll save them for you somewhere. So yeah, that'll be available.
So yeah, that's kind of, I guess, related to my question to you. You mentioned Phantom JS that gets used as a part of the compilation, I guess, when you're doing it from the command line. Does that then, how does that actually, I mean, it sounds like compilation then it also happens like live when you're, I mean, SCSS is what actually gets retrieved by the browser. Does CSS also get retrieved, CSS files, as before, or not?
Yes, you can load CSS files in the browser if you want, but that's outside of Fashion.
Okay, so Fashion only load, I mean, it only cares, I mean, it does the compilation itself.
Yes.
Creating its CSS inside the browser.
Yes. Now, Sass being a superset of CSS can, you can put CSS in your Sass files, and that's perfectly valid.
So what?
Okay. Sure. Okay. All right. I'm being asked to take the rest of the questions outside since there's a big crowd. So I'll be standing right outside. You can just ask any questions you have. Thank you very much.